She has published quite a few amount of work, papers from her work. Right, and now, of course, it's that hard work always pays. And I was just discussing with her. She is now at I think, at the right place. Although in the beginning there are new departments, she was telling me schools she has to establish. So she has to maybe work hard in establishing the facilities and department, but that will take. When you do something, you take pains, you learn something, and in the process you develop your personality, and it at the latter end it definitely pays. So let's now start to welcome Dr. Anupriya, right?
Yes.
Your alma mater, and we will now get enriched, benefited by her experience, what she has done after going from here. Okay, over to Siddharth.
Thank you, sir. Dr. Anupriya Mazumder worked as a senior research fellow in a DBT-sponsored Indo-Danish collaborative research project titled High Rate Algal Biomass Production for Food, Feed, Biochemical and Biofuel, and was awarded from Senior Research Fellowship. She completed her PhD from Food Chemistry and Technology Laboratory, Agriculture and Food Hygiene Department, IIT Kharagpur, in the year 2018. During her PhD tenure, she spent 4 months in Denmark Technical University as a guest PhD student. Dr. Mazumder is currently working as an assistant professor at Food Science and Technology Department, St. Joseph University, Bangalore. She has guided various postgraduate students for their dissertation work. She is currently in charge of Internal Quality Assurance Cell of FST Department and a member of Food Mills Association. Dr. Mazumder previously worked as research coordinator at Rejuvenation Therapeutic Corporation, a USA-based therapeutic food, drug, and dietary supplement company. I would like to invite Dr. Anupriya Mazumder ma'am to present her webinar on topic Valorization of Food Waste. I will request the audience to mute their mic and close their video during the presentation. However, they can post their queries via the comment box. Dr. Anupriya Mazumder ma'am.
Thank you, Siddharth. Thank you, Siddharth, because this is my lab where I learned everything. It's feel like privilege to learn from that. Okay, I have come to that status where I can also be introduced. There was a time when I was introducing other scholars or the scientists because I used to be there in all the meetings and all. So it's always feel happy to be come back to my lab where I learned everything, and whatever today I'm doing in my professional work, just because of the learnings and understanding we got it from that lab. And of course, sir, he always guided us like a father. So in this occasion, I also wanted to wish Mishra sir a happy Father's Day for being a professional father for all of us. So with his blessings, let me start my webinar today. And let me share my screen. Is my screen visible? Can you confirm, Siddharth?
Yes, sir.
Okay, so today I will speak about the project with my many.
Hide this dialog box, Anupriya, hide the dialog box.
Okay. How to do that, sir?
You can click this hide option. Beside stop sharing. Where this white box where the stop sharing and hide is written.
It is written ignore.
No, ma'am. Below the ignore, hide is written.
Okay, done. Now it is okay. Can you see?
Yes, it's fine.
Okay. So today I'm going to speak about a project that two of our outgoing MSc student has taken, that is valorization of food waste. They have done on valorization, that is addition of value to the food waste, to different type of food waste. One is the cashew nut shells, and another one is the different type of peels of pineapple, banana and cocoa shells. So before that, I'm trying to tell me. I'm from Department of Food Science and Technology from St. Joseph College, Bangalore. Coming academic semester, we will start as an institute of, or rather as an university, independent university. And this college has been so far recognized as one of the best colleges and excellence by UGC. And we have throughout A++ grade, and our grade is second highest in India. So with this brief introduction, let me start my project. So what is valorization? Why we call this valorization? So adding some value to something is called the valorization. So here in the food waste, which is otherwise we are wasting, that is of no use, we can give a meaningful dimensions or lot of beneficial commodities we can get out of it. So that's what it is. The project name is Valorization of Food Waste. So food waste is a global challenge from collection to disposal. The problem associated with food is this on the increase ranging from its starting from discharge, how it degrades, and it goes through a lot of contamination, also microbial contamination. So it's an hazard for health. So the most effective means of managing food is through effective sorting at source and recycling for industrial processes for production of the value-added products. So how we can get value-added product from the waste, and thereby reducing the option of incineration and landfilling, which is a major problem in big cities like Kolkata, Bangalore, Delhi. You will see many places is garbages are dumped after one another, and it's became hips and hips. So small research projects are carried on under my supervision to come out with an industrial solutions or a solution to get an industrial commodity and other value-added product from the food waste. So first today I will be discussing two projects. First project will be on the cashew nut shell. So if you can see, let me put my highlighter. Sorry. So this is the normal cashew nut it looks. So once it ripens, we take the cashew nut out of it. But after that, the kernel and inside one liquid is left over. So this kernel and the liquid is of no use. But few decades back, people start exploring, and there were research articles coming from the University of California that this liquid has a lot of potential activity for the industry and for the antibiotic industry also. So it started exploring. So what is that? Before going through the details of the liquid, I will be talking mostly about the cashew nut shell liquid. So what is cashew nuts is? So this is an cashew nut shell liquids is that it's coming from cashew nuts. This is a waste generated in cashew nut processing factories, has caused serious problems for a long time. So it is coming from the cashew tube. And the cashew nut shell liquid that is coming around 30 to 35% oil is the total quantity. So it's a huge oil. 35% of the cashew nut kernels is having this much oil. But if you examine this liquid through the many of the chemical activities, you will say this liquid is a mixture of 4 potential compounds, namely anacardic acid, cardanol, and 2-methyl cardanol. So these are the 4 different type of phenols is available. So we call it shortly, that is cashew nut shell liquid, as CNCl. So CNCl is naturally occurring substitute phenol, which can take part in variety of reactions. So what is it? It is a cheap and renewable substances. So CSNL based products are used in varieties of industry. This include brake lining, paints, primers, lacquers, cements, and is also used as an addition in many plastic compositions. But because of the extraction technology and the technology is not optimized, the cost is coming high. So our aim is to optimize the technology so the CSNL extraction we can get in cheaper prices. Before that, we want to characterize it. Apart from this anacardic acid, which is one of the main component, it is having antibacterial, anti-tumor, and therapeutic purposes. And the cardanol, which is one of the major bioactive component, it is used for making polymers, varnishes, paints, and braking fluids. So the concept is here. So the sustainable chemistry, where we are not using any other product for making this polymers, varnishes, we can use this cashew nut shell liquid. So this is sustainable chemistry is promoted by the utilization of low-cost renewable source like CNCl. So first, based on this project, we have come to 4 objectives: to extract cashew nut shell liquid from raw cashew nut shells using different type of solvents to understand which solvent will serve better to extract in the highest capacity. and to isolate major phenolic constituent present in the cashew nut shell liquid, and to characterize the cardinol using quantitative HPLC analysis, and to characterize anacardic acid by antibiotic susceptibility test. So here what I will discuss today, these are only preliminary tests done for the MSc project. We are still continuing and the results are still coming. We are continuing with this project. The next batch is continuing. So for this, for obtaining this 4 objectives, we have done some review of literature and we have taken this paper as a base for doing our research. So this papers are, first one is the process for isolation of cardinol from technical cashew, and second one is the studies on effect of various solvents on extraction of cashew nut shell liquids and isolation of major phenolic components. Third one is the synthesis or the characterization, how the CSNL will be characterized. And fourth one is the characterization of the anacardic acid and seeing assays how it is working. So outline of the work was like that. First we have taken, this is a raw cashew nut shell. Then we have broken it, we have taken the cashew nut out and now it's the broken shell. From there we have extracted natural CnCl by Soxhlet apparatus. Initially we have done with Soxhlet apparatus and tried different type of solvent. And from there we have isolated anacardic acid and we have characterized anacardic acid using antibiotic susceptibility test. So this is our outline for doing the anacardic acid isolation and characterization. With the same technical, that is natural CSNL. So there are 2 types of CSNL, CNCL. One is natural, where we are not using any heat process. So naturally how much we can get, we will get. And next one you are using technical. So here we are modifying the extraction process. We are using different type of expeller, mechanical extraction. We are roasting the kernels to get the more cashew nut shell liquid. So this is the technical CNSL from lab, we got it, and isolation of cardinol has been done. So this is the second polyphenol and we have characterized using the HPLCs to see that it is the cardinol or any other component is there. So materials we used raw cashew nut shells, extracted CNSL extracted by different type of solvents, acetone, technical CSNL where we have roasted the cashew nut shells and done the extraction. Then we have isolated cardinol and anacardic acid and cardinol standard from different industries we have taken and we have done the reference estimation how much it is there. And solvents we have used, initially we have used all the solvents to see where the extractability is coming high. Soxhlet apparatus, spectrophotometer and HPLC were used as an instrument. We have used Mullen, Hinton, agar and other whatever classifiers and chemicals required for the estimation. So first we have focused on extraction of cashew nut shell liquid from cashew nut shells. So here we have used 3 extraction methods. First is solvent extraction, second one is the thermal extraction and third one is the mechanical extraction. So the composition of CHNL differs depending on the method of extraction because we have used 3 different type of extraction. So natural CNCL, which is extracted by using cold solvents without any heat or mechanical extraction, contains anacardic acid up to 60 to 65%, cardinol 10 to 15%, cardol 20% and traces of 2-methyl cardol also. But this is in trace amount, not in. So we did not prefer it to go for the next steps to purify it further. So technical cashew nut shell liquid is extracted by roasting. Here is a difference. For the natural CNCL, we do not use any type of temperature. Elevated temperature, we have done it with the cold solvents. But for the next one, we have roasted the cashew nut shell at higher temperature, causing decarboxylation of the anacardic acid to cardinol as a major component. So 60 to 65% and other CNL components include cardol, that is 50 to 20%, polymeric materials also we get here, that is 10%, and again traces of 2-methyl cardinol. So how we have done the extraction? So extraction of CNCl from CNS by using Soxhlet apparatus and used both polar and various non-polar solvents. So 500 ml of solvents was added into the round bottom flask of Soxhlet apparatus and 50 gram of crushed cashew nut shell was added to the thimble and fitted into the Soxhlet extractor. So the solvent in the step was heated to its boiling point and the vapor produced was subsequently condensed by water flowing in and out of the extraction setup. So this process of heating and cooling continued until sufficient amount of CSNL or the maximum amount of CSNL we obtained. So at the end of the extraction, the thimble was removed and while the remaining solvent in the extractor was added into the round bottom flask. So concentration of each CSNL sample extracted with different solvents in water bath at the temperature above their boiling points and weighted the concentrated sample. So we have continued same for the anacardic acid samples. Here we have for anacardic acid, we have taken extracted CL which we got from the previous experiments. From that, we have taken 50 gram and dissolved into acetone, that is 300 ml, and calcium hydroxide was added in the portion until steering, and it kept under steering. So after adding the calcium hydroxide, the temperature of reaction mixture was raised up to 50 degree and steering was continued for 3.5 hours. After completion of the reaction, the precipitation was taken and filtered and washed with acetone and dried for 2 hours. So calcium anacardate treated with distilled water and 11 molar HCl was added and constantly stirred for half an hour. So the resultant solution was extracted with the petroleum ether. So you can see this is a series of extraction we get to get the anacardic acid. It's not a single reaction or a single solvent. We are using different solvents for extracting and removing the other that is present, that is debris are present, to removing that. So finally the combined organic layer was washed with distilled water, dried over anhydrous sodium sulfate and concentrated to get pure anacardic acid. So this pure anacardic acid, we have done diffusion susceptibility test to understand is it actually having any antimicrobial activity or not, or the process, the extraction process which we are doing, is it sufficient to get the, or it is destroying the antimicrobial activity. So this purpose is to determine the sensitivity or resistance of the pathogenic aerobic, facultative anaerobic bacteria to various antimicrobial compounds. So the pathogenic organisms are grown in Moulin Hinter agar in the presence of various antimicrobial impregnated filter paper disc. So the presence or absence of growth around the disc is an indirect measure of the ability of that compound to inhibit the organism. So we have chosen 1 gram positive organism, that is Staphylococcus aureus, and 1 gram negative organism, that is Escherichia coli. So the test was carried out usually, and after that we have checked under the colony counter to see. So we have allowed the diameter of the zone inhibition resulting from the antimicrobial action of the extract was expressed in millimeter. So the test was considered negative when there was microbial growth around the disc as well as negative controls. So after this, we have done isolation of cardinol. This is all about anacardic acid. This is the one of the major bioactive component coming from cashew nut shell liquid. So we have done the isolation of cardinol. So same method, different methods we have followed, like technical CSNL 100 gram we have taken and dissolved in methanol, and ammonium hydroxide was added and stirred for 15 minutes. We have washed it and extracted with hexane. After that, we have again washed with 5% HCl solution followed by distilled water. We have added activated charcoal and added to organic layer, stirred for 10 minutes and filtered through Silite. So the filtrate was dried over anhydrous sodium sulfate and concentrated to get pure cardinol. So for this, seeing how much it is present, cardinol, is it pure or some other component, we have done some HPLC standard. So we have used this HPLC instrument comprising two 510 reciprocating pumps. These are all, and we have used LC18. That is the column we have used, and the flow rate was 1.80 ml per minute and absorbance was monitored at 280 nanometers. So each analysis was carried by dissolving 25 mg of sample in 5 ml of acetonitrile and filtering through the syringe. Okay, so now we also have done the antioxidant. Many of you have done, so I'm not doing in the details of antioxidant activity. So we have done DPPH studies. So now comes the main part, what we get out of it after doing all of the series of extractions, and what is our final results and how it is differing. So here is the CSNL obtained with the hexane solvent, that is a non-polar solvent. We got is 22.1469 per gram. This is for 100. And CSNLs obtained with ethyl acetate, which is in higher side, 25.4492 gram in from the 100 gram. And CSNL obtained with acetone was highest, that is 28.0272. So our actually, this is the original picture of the extract. So in the discussion, we can tell that cashew nut shell liquid was extracted from raw cashew nut shells using both polar and non-polar solvents. The percent yield achieved after extraction using various solvents was compared. Among all the solvents, acetones give maximum amount of cashew nut shell liquid, and the CSNL obtained with acetone solvent was estimated around 28 gram. So when all the CSNL obtained were compared using different solvents, the acetone solvent proved to be more efficient than the others. This is after all doing with the extraction of six different solvents. We have come down to 3 different solvents, that is hexane, ethyl acetate, and acetone. And finally, we have optimized with optimum results are coming with the acetone. So next one is the cardinal obtained. I told there are 2 types of extraction. One is the extraction with the normal temperature, that is natural CSNL, and another one the technical CNCL. So cardinal obtained from technical cashew nut shell liquid is 37.320 gram, and cardinal and anacardic obtained from natural cashew nut shell is 15.368. So here what we conclude, so anacardic acid is more abundant in solvent extracted CSNL than in cardinal. So anacardic acid isolated was 15 gram from natural, that is without giving any temperature, and cardinal isolated from technical CNCL was 37 gram. So technical, which we are using a roasting process, CNCL is made from roasted shells and primarily comprises cardinal with traces of anacardic acid. The carboxylic group of anacardic acid has thermal properties, that is tendency to get converted to cardinal. And we have done HPLC also to identify is what we are getting is the sample we are looking for. So HPLC was used to confirm the identity of cardinal by comprising it to the standard sample. Peak 11, that is the peak 11, you can see it's a prominent peak, is found in both the standard and the sample HPLC chromatogram as a reference chromatogram, indicating that cardinal was present. Hence, the isolated cardinal is pure as the standard sample. But the purity, how much it is, we did not determine. We only see it's the peak is coming, so that means, but purity is a long process where we have to train the HPLC. And we have to do it with the standard curve, which we do not do, but we have identified that what we get, it's a pure cardinal. We have done the antimicrobial activity for anacardic acid also. I have told in the material method section, that is for the Staphylococcus aureus and the E. coli. We have got a zone of inhibition 9 millimeter and 8 millimeter, which is not very high. Maybe it's because of the purity. The purity, we did not do any purification process. That's maybe the reason, but it is present there. So it is the proof that it is having antimicrobial activity, and the acetone extract you are using is not destroying the capacity of the antimicrobial activity. So this we need to optimize. So this is the discussion. So although it is lower 9 millimeter and 8 millimeter, but the antibiotic or antimicrobial activity is present. So we have done antioxidant activity also. This is for the DPPH. So in discussion, what we can tell for DPPH, the antioxidant effect is proportional to DPPH disappearance in the test sample. How much absorbance is inversely proportional to the antioxidant. As a result, the antioxidant impact may be easily evaluated by measuring the decrease in UV absorption at 520 meter among 2 samples. Anacardic acid shows the highest antioxidant activity than the cardinal. So anacardic acid is the yellow one and the green is the cardinal one. So this is the conclusion for the project 1. So the renewable sources are emerging as a variable alternative to fossil fuel for replacing petroleum-derived, non-degradable and less sustainable products. So cardinal has been identified as one of the promising renewable resources. Due to its unique structural characteristics, it is less expensive and readily available. Anacardic acid is a phytochemical that has a wide range of bioactivities, including antimicrobial, antibacterial properties. And this we are getting from a food waste. We are not using any type of natural resources for that, which is left over after taking the cashew, we are taking from that. So this is a valorization or the value addition to the cashew nut shells, that is cashew nut shell liquid. So this is about the first project. Second project, one of our MSc student has tried to utilize the agricultural waste to produce biodegradable eating plates. So which plates usually we use? Thermocol plates or plastic plates. So here we are trying to make an eatable biodegradable plate from the agricultural waste we are getting. It can be pineapple waste, or we have taken pineapple waste. So why we have chosen this project? Because agricultural waste generation and management, especially from the fruit and vegetable processing industry, is huge. Even household consumption in hotel, it's huge. So Agumathu et al. 2009 indicated that it is expected that 998 million tons of agricultural waste will be produced a year in coming future. So this was a prediction in 2009. Already maybe it's more than that. And fruits and vegetables account for the highest food waste, that is 45% of total agricultural waste. So in Asia, it is 37% of the total agricultural waste. So this waste is generated, apart from being occupying a dumping ground, it's a social economical concerns because they contribute to water pollution, foul odor, serve as a breeding ground for flies, mosquitoes, rodents, diseases, and many other things, which is an added burden to the cities. So what we have taken and how we can solve it minimally within our capacity. So adding value to the waste, that is, we are having high content of cellulose in the fruit and agricultural waste. And pulping technology we have used, and we have making a product which is lucrative. So it's a biodegradable, although it will be a bit costly, but it is biodegradable. It is not adding any harm to the nature. So these are the two review literature we have taken for doing the project. So objectives are basically two, not previously we have, for the previous project we have many. Here we have taken a simple objective to develop biodegradable plate using agro waste such as pineapple waste, banana peduncle waste and cocoa waste, and to evaluate physical properties of this biodegradable plates. So what we have used, three different formulations. First one is the pineapple waste comprising of skin and crown. And here formulation 1, we have used 100% of the pineapple waste. Second formulation, we have taken 50% of the pineapple waste and 50% of the banana peduncle waste. 50%. And then the third one, we have not taken any pineapple waste. We have taken 50% banana peduncle waste and 50% cocoa waste. So these are all the original picture of the raw material which has been taken. So this is the pineapple waste, that is skin and crown. This is the banana peduncle, and this is the cocoa waste, that is the shell. So how we have done? We have done the grinding, then we have done soda pulping. These are the pictures. So grinded pulp, soda pulp raw material, dried pulp sheet, and then we have hot pressed machines. So after that, although it doesn't look like exactly what when we are thinking of the eating plates, but pineapple waste plate look like this, and pineapple waste and pineapple peduncle waste plates look like this, which is not so bad, but it's biodegradable. So it's nature friendly. We have done physical properties for that. Thickness is almost 2 millimeter, and for the banana peduncle, because the mass is heavy, it is 2.51. We have done grammage, that is how much mass is present. So mass of the pineapple waste plate was around 98 gram. Mass of banana peduncle and pineapple waste plate was it's heavier because we are using two type of waste together, 117 gram, and mass of banana peduncle and cocoa plate was 26 gram, and diameter for all these three plates are around 20 centimeter. Water absorption capacity, that is done using the COB method, ISO 535. It is 600, 340 and 160. And the biodegradation, which is actually we are looking for how much biodegradable it will be. That is the main purpose for using those wastes. So we have taken this. How we have done, 3 pieces of the plates were retrieved. After 15 days from there, they were buried under the soil and dried. And we see pineapple waste plates, it's having degradation of 86.9%. 76.10%, and banana peduncle waste were 73.17%. So it is almost done for the 2.5 months for the project, and we see at the end of the project it is coming this much. So here obviously banana waste, because it's a simple, it's not a mixture of any of the other compositions like pineapple and banana waste. So it is the highest degradation was found in the 86.98%. So as in conclusion, we can tell, so we propose that waste utilization by making biodegradable plate from the agricultural waste as an alternative for plastic single-use plates, which is not biodegradable, and according to physical studies, and biodegradable serving plates made of banana peduncle and pineapple waste, that is formulation 2. So this is the formulation. This is the formulation 2, 50% pineapple waste and 50% pineapple peduncle waste. Gave the best result, having least leachability, because when you put something like some curry and all, it should not leach. Optimum water absorption capacity and most acceptable appearance. So second formulation was best one of those. So here is about the 2 project, and I want to acknowledge the hard work of my 2 peer MSc student, Sneha Marin Matthew and Atulya CP, those who worked in the project and guided them. And also I'm acknowledging the Cashew Export Promotion Council of India and 3T Biosolution providing all the necessary facilities. Thank you.
Thank you so much, ma'am, for the wonderful presentation.
Can I stop sharing?
Hello? Yes, ma'am?
Can I stop sharing?
Yes, ma'am, you can stop. Thank you so much, ma'am, for the excellent presentation. You have utilized very gratefully this cashew nut cell oil, which actually creates irritation in the skin if you get touched. In the industry, we used to try to avoid any skin touch from that oil. Okay. So we can have some questions from the audience. Anyone who want to ask any query or doubt?
Sir, do you want to add something? Any comments on the project?
You are asking from me?
Yes, sir. Because this is the first batch of student I'm started with. First time I'm doing mentoring students.
Approach is right, but there are always a scope of it. We can discuss separately the problem, but is there any comment? We can take query from the participants.
Okay, someone has said to share the contact for further combination. Sophia Dixon. Yeah, we will share the contact.
You can share my number.
And
180 degrees centigrade. Hriday sir has asked. We have used cashew nut 180 degrees centigrade for technical CSNL.
सर सुकुमार जी, हाँ बिल्कुल पूछिए.
Sir ji, good evening. Namaskar.
Good evening. Good evening.
It's a wonderful presentation, Dr. Anupriya Madam. Thank you. I enjoyed a lot, and we handled these 2 types of projects earlier, like from this shell and that, and or some of the, some of the companies who use our N2P2 park, something like that, incubation center, they use this kind of product from your shells, like what you have made it from this pineapple waste and all this. In case of pineapple waste, actually, why you have not selected any food materials? Because one of our PhD students actually has done some work on extraction of this bromelain content, which are highly available in your pineapple, peels and all.
For meat tenderization.
And more than in rind also. So, and bromelain is very good, for your health, especially as far as the neurological thing is concerned, brain is concerned. So I was expecting some kind of good work that year. So next time, if possible, because a lot of contents are there. And you can have a good price for that if you develop this year, because you
are right, sir. We are approaching 2 institutes now for the bromelain extractions.
Yes,
and maybe our next batch of students will do for the meat tenderization. We want to see how we can optimize bromelain for the meat industry.
And recently we are having some, Tech Bharat program, something like that.
CFTRI Mysore.
And Professor Mishra sir is like my teacher. I respect like my teacher, my Guruji actually, like I feel. I was not having any, I was not fortunate to get any, I wanted to do postdoc with him actually. Somehow the system did not permit me actually. Earlier I was trying actually. Anyway, I conveyed him also. But even then he's my Guruji like that. I respect like this. So in Tech Bharat, some of the people are interested about this. And in our PMFME project also, some of the Kishans means that farmers are highly interested to get this kind of PLN or something. So next time if possible you can do some of the, and you are near to my only maybe 3 to 4 hours journey. Kindly pay a visit and show that to our institute.
There you are, sir.
Okay, I am in CFTRI myself. So
Okay.
myself will be near.
Okay.
If any kind of, I am associated in food engineering department, and we are having a very good opportunity for of carrying out that, pilot plant work. So I am in pilot plant only, and some other labs also there. So you will be having ample opportunity to carry out your work in large scale production when you are going to do all this. So ample opportunity will be having this one. So these are the things, and I just wanted to know. And second thing, the plate you have made, is there any hygienically, it is any problem? Is there or something like
No,
that?
we have not gone up to that. Only biodegradation part we have seen. Our next batch student will continue where the previous student has left.
So I have not seen any like sterilizing steps or something, some of the, so I was a little worried about, because the shell part or the shell leaves we use or something, there is no way. And this kind of bioplating or something, is there any hygienic something? So these two actually questions came into my mind, so I thought I'll ask them. But otherwise, wonderful presentation. And I am also enriched a lot with this kind of, and generally I attend, sir knows this one. I feel very happy to be a part of this. Thank you very much. Thank you, sir. Sarji.
Thank you.
Thank you.
Thank you for your valuable suggestion. In fact, Anupriya, you have taken a very right area for your research development, because this is the byproduct and waste utilization in food processing, zero waste processing, and near zero waste processing is now a very, very highly demanded area.
Yes, true.
So you can take a lead from Dr. Sukumar Devnath telling that normally extraction is good, you can go for extraction. But at least if you are not able to go for extraction, find out in the edible plate what is the bromelain content.
And another thing, you can see the LC also, life cycle assessment. That we are doing also. We are having good softwares also, and that aspects also see. We nowadays waste to wealth material, and the industries are asking about the life LC and give the values and so that it will be very fruitful for you.
You can ask your students to take our post-harvest operation course also.
Yeah, definitely, sir. Definitely, sir. I'll be attending. Definitely, I have registered. So I have already contacted my students.
There also we touched upon some area.
Right,
1 week we at least we have developed that valorization and green technology and waste utilization.
Last lecture is there.
गुड वर्क अनुप्रिया. इस तरह से थोड़ा सा अभी शुरू में यू हैव टू डेवलप, ऑब्वियसली थोड़ा लगेगा. और
अभी थोड़ा तो मतलब बहुत ज्यादा बॉटलनेक्स है, बट आई एम डिटरमाइंड, आई विल डू.
अच्छा, maybe most probably I will be in Bangalore in the second week of July.
Okay.
So if that time your college you open, then
sir, if possible, kindly sir visit to our place also. We'll be very happy to have you here.
If I find some time, definitely I will.
Definitely.
At least अनुप्रिया क्या, तो हमारा जहाँ रहेंगे हम वहाँ से I will be in इंदिरा नगर.
इंदिरा नगर, ओके. बहुत पास है इंदिरा नगर से.
जीवन बीमा नगर. So then I can find some time to work. So good, continue doing good work. और अच्छा है, life is very long, और अभी से शुरू में ही अगर एक डिपार्ट बन जाएगा, that will very, very so is there any other questions? वसुधा ने कुछ नहीं पूछा. वसुधा is here.
हाय वसुधा, पूछ ले.
रेस ने पूछा है, सुषमा ने पूछा. वसुधा are you here or is gone?
Vasuda ma'am,
she has joined, I think now. She maybe
he left her.
She left. Okay, good.
Ma'am, I have a small query. Like there is a term called edible plates. So this edible plates and biodegradable, is there any difference or both are?
These are not, although these are made from the food waste, but you cannot eat it. The taste is not good and it's like more fibrous. It's not edible. In Bangalore, one of the startups, they have started with edible cutlery, like spoons, forks and all, that after eating you can eat that also. It is with some flavors, but these are not. These are only, we are trying to make one biodegradable plates, but these are mostly cellulose.
Those edible
component itna high hai.
plates are made with some kind of.
They use some kind of enzymatic reactions to do that, but here it's not. It's an edible, not an edible. It's a biodegradable.
Okay. Thank you.
Thank you.
Okay. Is there any question from the audience? Okay, I would like to invite Jasvi ma'am for vote of thanks. Jasvi ma'am.
Was Sri Jayasri there when you were here?
He joined back when he joined in 6.
Yes, sir. I entered and ma'am left, I think.
Yes.
But we attended her defense party.
Okay.
Thank you so much, ma'am. First of all, today is Father's Day, and I think the whole FCTL family wishes our mentor, the parent who have always supported us in all the walks of our life, to sir and all the seniors, especially to sir, happy Father's Day, sir. And regarding the webinar, it's a privilege to have one of the senior most research scholar whom I have seen working, and she was in the last phase when I joined her. Anupriya ma'am, thank you so much. The the webinar was extremely delightful and extremely knowledge seeking. Valorization, and especially choosing a very innovative product like cashew shell liquid, which is barely out, but it's extremely harmful, as it is being known that that liquid creates rashes, and it sometimes blackens the fingers of the laborers also who work on that. Extracting them and using it for a better purpose is something we would look forward to, and more research from your side, as well as going on the area of sustainable development and utilization of zero waste. Utilization of fruit pulp and fruit waste for production utensil is again a very new and innovative technique, which might start a way for entrepreneurship in further. As a budding academic, it's an immense pleasure for us to see you grow so much. Thank you so much, on. Thank you for the audience and the FCTL webinar team who is deliberately hosting and the invitation. Thank you so much. Thank you to our mentor, also to Start Award. Thank you, everyone.
Thank you, Jayashree. Thank you, sir, for the platform.
Okay, thank you all. Bye-bye. Thank you.
Bye-bye.
And Father's Day blessings to you all.
Thank you.
Thank you. Thank you. Thank you.
Happy Father's Day.
Stay blessed.
Thank you, sir.
For the
Happy